going to take me a few days to look through all of those spreadsheets and reports, and so I'll try and grade those as quickly as I can, but I try and be thorough about it, so it may be next week sometime before you see your score in MU Online. In the short term, there is homework 13, which is due on Thursday. And of course, we have Thanksgiving on the medium term, so you'll get a break from not only this class, but all of them. I know it's quick to have another assignment when you've just done the project, but that's just kind of how the material works out. So before class on Thursday is when homework 13 is due. And today what we're going to be doing is looking at something called payback analysis. And this is an extension of something we've seen before, and so it's not like a completely new topic. It's just maybe using it for decision making, something that we've done before. Before we get into payback analysis, are there any questions? Okay, well, in payback analysis, the types of questions that we're going to be trying to address is if we're going to buy a new piece of equipment and we know what is the first cost of the equipment, and we know what is the interest rate and the net revenue each year, meaning the amount that's coming in minus any sort of operation costs, then what we're going to try and figure out is how long would it be until a loan used to finance the purchase would be paid off. And so we're going to do that unrecovered investment balance spreadsheet again. So you remember that we went through the process of over time looking at the beginning there was some unrecovered investment balance because we had taken a loan and purchased a piece of equipment, and then the amount increased during the first period because of the effect of interest. So the first thing I'll remind you is even though this is all about debt that you owe, and we think of debt as minus signs, the fact that we're calling this unrecovered investment balance is already taking the debt aspect of it into account. And so it's okay for us to draw the line upward as long as we're specifying that the sign of that direction is as a debt. So we borrow some money, and at the end of the first period, the amount that we owe is even higher because it's the principal plus the interest. And so if you remember, the columns that we had was the unrecovered principal balance at the beginning of the year. And we don't start at time 0 because each of these columns is specifying either the beginning of the year or the end of the year. So the beginning of the first year is time 0. And that's what this column here is reflecting, is it's $85,000 at the beginning of the first year. And then during a 1-year period, the interest is $3,400 because in this illustration what we were saying was 4% interest per year, and it's based on this unrecovered principal balance at the beginning of the year. So then at the end of that first period, the total amount due is the sum of those two columns, the interest and the previous amount. And then there's a payment that we can calculate to find out over the course of 5 years how much has to be paid back. And the way that we calculate this amount that was in column 4 was to find A given P. So find the annual amount that has to be collected to, over the course of 5 years, retire that $85,000 debt. Now, of the $19,093, a portion of it was principal and a portion of it was interest. How much of it is interest? We just have to look at column 2. The rest of it then goes towards retiring the principal. And so over time, the unrecovered investment balance decreased. And so this is the end of the first year, and the amount due at the end of the first year is the same as the amount due at the beginning of the second year. So we're breaking up each of these time periods into the end of the time period and the beginning of the time period. So this, I hope, isn't completely unfamiliar. It's things that we've seen before. So some terminology that we're going to use when we do the payback analysis is the payback period has the variable assignment n sub p, and that's how long we will be calculating the time for the revenues and or cost savings to cover the initial investment plus the rate of return. So it's not just the original outlay, it's not just the first cost, but we're also assuming some interest rate. Now, I'll remind you that it's not always new revenue that can be counted towards covering the payback period, because sometimes you'll be saving money. Previous expenses that have been turned into savings. So, for instance, if you have a water heater and it's using a lot of electricity, like in my case, I think my water heater is probably using about $30 a month of electricity. So if I bought a more efficient water heater and suddenly my costs dropped to $10 per month for the electricity, then that savings of $20 a month that I used to spend, that's counted as in the same way as a revenue. Even though it's not me earning an increase in my salary, it's just money that I used to have to spend and now I don't have to spend it anymore. So either of those can count towards the payback period. Now, simple payback is just the case when we assume an interest rate of 0%. So that's not what we usually will be doing calculations on. More frequently, we'll be discounting future amounts when we take them to the present. So that means we know the time value of money dictates that money in the future will be less valuable because prices are increasing. And so when we discount all those amounts to the present value at the interest rate, then the payback analysis tells us how many years until we've recovered the initial investment. Now, how do we use it? Remember, I always tell you on quiz and exam problems that you should understand the decision criteria. And so decision criteria is things like if the internal rate of return is greater than the MAR, then that tells you the project is acceptable. Or if the incremental benefit cost ratio is greater than 1, then that means you should choose the more expensive alternative. So you should have, just as a reflex, the ability to rehearse what's the decision criteria for every kind of analysis. Now here, payback analysis is only used for initial screening. When we compare two options, we can get into trouble if we always pick the one that pays off more quickly. And I'll show you an illustration of that today, why that's the case. So in some ways, this parallels internal rate of return. Remember, with internal rate of return, we couldn't pick which project is best just looking at the IRR. And same thing with benefit cost. We can't decide which project is best just by looking at the benefit cost ratio. We have to go a little bit deeper. So here, what I'm saying is payback analysis will tell you whether or not an item is acceptable. And it's acceptable if the anticipated useful life is longer than the payback period. So think about what that criteria means. It means don't buy equipment that is going to wear out faster than you can pay it off. I mean, that's pretty logical. You know, it's the same thing you'd do for a car. You wouldn't want to buy a car and be paying it off while it was junked and you're not driving it anymore. So you can't earn revenue for items that are no longer in service. So it can be used for initial screening on it all the time, but it can only be used for comparison if the two items have the same useful life and revenue. So you need to really understand that limitation of payback analysis. You can only use payback analysis to pick which one is best if the two items last the same number of years and they're either bringing in the same cost savings or the same additional profit. And if they are, then the option that's best is the one that you can pay off the quickest. And so that's going to essentially be the one that is the cheapest to begin with. Any questions so far about payback analysis? Now, the reason why you can only use it for initial screening if the two items have different useful lives or if the items have different revenues is that after the item is paid off, payback analysis disregards what happens after the payback period. So it could be that one item is paid off more quickly, but its competitor, the other one you're considering, is able to generate even more revenue after the payback period. And so in that case, just picking the one with the quickest payoff would not be able to see which option is really best. And that'll be the problem with the comparison that we do in today's in-class exercise. So to make sure that we have enough time for that, let's get right into it. Here's the setup. Our company has a MAR of 8%. So we're going to be using 8% as the interest rate for discounting revenue. Our company is going to purchase some equipment that has an anticipated useful life of 18 years, and the present cost is $92,000, and it's generating an annual net revenue of $11,000 each year. All right, so I'm going to give you the handout for this. Part A, you need to do on paper. So on the handout, I'm going to give you the factor tables are on the back of the paper. So first, solve it on paper, and then don't begin with Excel or the computer until you've already figured out the answer on paper. Now, in Part B, you're going to use Excel, and I tell you which column titles to use to do the unrecovered investment balance. But in Part C, there's a new function that I'm introducing here. It's a function called NPER. And what that means is number of periods. And it tells you the payback time when you enter an interest rate, when you enter the payment amount, and when you enter a present value. So the form of the equation is in the handout I'm going to give you, and I'd like you to try to figure out the equation. You know, when you start typing it in, Excel gives you the little hints and prompts on what data should go into which field. So of course I'll demonstrate it on the screen, but first of all I'd like you to see if you can figure it out before that demonstration. So remember, the factor tables are on the back for this first problem. And I've bolded these words intentionally. There's a couple of additional hints here on the screen. Okay, so let's just make sure we're all on the same page for this part A. So in the problem statement it says that the present cost is $92,000, the annual is $11,000. So the ratio of P to A is 8.364. So now go to the column on the 8% table on the back of your paper. Find the P to A column and start going downward through there. And you can see that you're approaching 8.34. And so it looks like it's between 14 and 15 periods. And so what that means is that 14 annual revenues of $11,000 will not quite cover it. And 15 will be over. So that means that it's 15 payments that puts you into the break even. So you'll break even and have a little additional profit after 15 years. So what we could say is after 15 years. All right, so that's what this manual method tells us. Now in part B, we're going to try and find out the specific amounts of the cash flow each month using Excel. So I've given you the column titles. Go ahead and start up Excel, and we'll have year, amount of money for each, the present value where you're discounting at the MAR, and then the unrecovered investment balance, which I've told you what we're doing. It's the present worth of the inflows from the initial cost. Let me show you how this final column is calculated in case you didn't notice that. All right, so think about what the title means. It means the unrecovered investment balance, and so you can think of it a couple ways. If you're buying this item out of your own pocket, then it's how much of your investment to purchase that item hasn't yet been paid back from the new revenue that you're receiving. That's one way to think of it. Or the other is how much do you owe the bank on the item if you borrowed the money rather than using your own. So at time zero, the unrecovered investment balance is the full amount that was borrowed. So it's just this first amount of $92,000. So you owe $92,000. Now, after 1 year of operation, you have $11,000 in revenue come in at the end of the first year. The present value of that amount is $10,185. So your unrecovered investment balance is going to be the previous balance, which is in present value terms, and how much new revenue came in for that year. So all I said is the cell above plus the cell to the left. And so then that's where the $81,815 comes from. And now that same pattern is going to hold true. It's the one above plus the one to the side. And then that tells me, you can see the unrecovered investment balance is coming down. And what we'd calculated manually using the table was it was 14 point something, between the 14th and the 15th year that the break even occurs. So what is the payback time? It's 14 point something years. And essentially, it takes 15 years of operation to pay back because we haven't paid back in the 14th year. And if we receive these amounts in discrete payments at the end of each period, then it will be 15 periods of operation before the item is paid off. Pretty easy, right? So think about all of the different things that these built-in financial functions that are in Excel. There's PV, the present value function. There's the future value function. There's the PMT function where it's telling you the amount of the annual recurring payment. And so now we know there's a function that allows us to solve for n. I mean, if you think about the types of information that goes into these problems, there's problems where you're trying to find the P, problems where you're trying to find the A, problems where you're trying to find the I. The IRR function, built-in financial function in Excel, is finding an unknown interest rate. And so now we know a function that solves for an unknown n value that brings this into balance. So what this is saying is 14.4 years. Now, of course, what we're saying in this setup is that the amounts occur in discrete payments at the end of each period. So to pay off the equipment, you always have to round up. 15 years is how long it takes to pay off the equipment. It's not yet paid off in the 14th, And since we don't receive that year's revenue until the end of the period, then it takes 15 years of operation before we have now gone into the positive range. Any questions about this part 1 problem? All right. In part 2 of the in-class exercise, we're now going to use payback analysis to compare equipment. And I'm going to walk you through an illustration of why you can only use payback analysis for initial screening. Payback analysis will give you a thumbs up or a thumbs down on each piece of equipment, but it won't necessarily tell you which one is preferable of machine X or machine Y in this case. And the reason why, in this case, they have different useful lives and different initial purchase prices. And so if we just picked the equipment that could be paid off the quickest, then we might miss something important. And so think, if you were going to be buying a car, the car that has the overall lowest cost of ownership per year is what you'd want to make your decision on, not what car can you pay off the quickest. Because you could probably find something on Craigslist that you could pay off in 2 months, but maybe it's not going to last for very long, or maybe it would have high maintenance costs, or whatever the case may be. So in this case, first of all, I'd like you to do the unrecovered investment balance for both machines over time. So find the same columns that you did here. It's important for you to practice it. So do this same analysis for machine X versus machine Y and find out how many years to pay off. Now remember, you round up to the next whole year. And then answer these questions that go along with part A. And then in part B, I'm asking you to do a present worth analysis, because remember, present worth analysis will never lead us astray. It'll always tell us which item is best. And so we're going to just compare these two alternatives and which one's actually the best and which one maybe would look the best if we were going to misapply payback time.
So you pay it off and then you buy it.
Okay, so let's take a look at what this analysis tells us. So on the basis of unrecovered investment balance, we can see that machine X becomes profitable at the end of the 6th year, whereas machine Y doesn't become profitable until the end of the 8th year. So on the question here, the unrecovered investment balance for both over time, the payback for machine X is 6 years, for Y is 8 years. Now, are they acceptable on the basis of initial screening? That's how we're supposed to use this unrecovered investment balance. And so what's the criteria? What's that?
Payback for the end of the service life.
Exactly right. So we should be able to pay it off before the equipment is retired. And so 6 years was the payback time for machine X, and it lasts for 7. So that's good. That means we will have a profit. For machine Y, it's paid off after 8 years, and it operates for 14. So both of them are acceptable. You know, later on when we do the present value analysis, both of them are going to be profitable equipment. So each is acceptable, but if we were going to just pick the one that had the shortest payoff time, it would maybe look like machine X is the better option. But it's not the better option, because if we repeat the cycle for machine X, which is what we have to do for present value analysis, the reason why we repeated the cycle and we purchased the item again in year 7 is that they have to, two alternatives have to have the same useful life to be able to compare them. And so now if we do this NPV function, which is probably the easiest way to do it, equals NPV at an interest rate of 8%, and the amounts are all of the amounts that aren't at the present, and then outside of the NPV function, we're going to add in this initial purchase price. Let me move that to a place where it's a little bit wider, the cells already. Okay, 5,730. I guess the other way to find the present value is these are all present values. And so if we just take the sum of all of these amounts, that's going to tell us the same thing, that the sum of the present values is 5731 compared to, for the other one, just for consistency, let's both do the NPV function, so net present value using the rate of 8%, and then only the amounts that are in the future. And then outside of the NPV function, we have to add in the amount that's already at year 0. So the net present value for machine Y is greater. So even though it takes longer to pay off, it's the better option. Why? Well, for some reason, towards the end of its useful life, it has an increase in revenue. Like, how realistic is that? Well, maybe at the end of the useful life you stop maintaining the equipment as well. Like, you're not going to the dealer and having all the exact stuff done that they say should be done every 5,000 miles. You're just maybe putting gas in it and hoping it runs as long as possible. That's kind of my approach on my car. I'm not doing the required service interval, like all the little things, get your floor mats checked, have the gas door oiled and all that stuff. So anyways, option machine Y is better because present value analysis will never lead you astray. It'll always tell you which of the two alternatives is best. And so if we go here to the in-class exercise, based on present worth, machine Y should be selected because it has the greatest present worth. So my hope with this in-class exercise was that it would show you how you can use unrecovered investment balance and payback time. You can use it for initial screening, but you can't use it for comparing equipment. Okay, so we've got a little bit of time left over. What I'm going to do is I'm going to pull up the solution to the project.